I suppose I better introduce Ed, seeing as he probably shouldn't introduce himself. So this is Ed. Ed is one of the senior research software engineers at the Academy of Advanced Computing, and he's going to give us a little introduction to Python. Out of curiosity, Python programmers, most of us-ish, some familiarity. Cool. Good. Well, thanks, Ed.
That's a good place to start because I haven't been very introductory. Whatever. I haven't been very advanced either because I'm not a very advanced person. So, a quick outline of what I'm going to talk about. I'll start off with some confessions. Then I'll talk about general principles you can use on small repositories, even if you're not working with big repositories, things you can do that will make your life easier. Then I'll try and explore a couple of considerations with when you start moving to larger repositories, things you have to consider you didn't have to consider before. And then I'll look at a couple of case studies. So the confessions I have. So the largest Python project I have built contains, guess how many .py files?
5, 8. Well, but it's not the number, maybe.
Order 10. So yeah, between 8 and 12-ish. So I have looked at repositories that have more .py files to base this talk on. I'm not drawing on my own experience though. I'm drawing on the experience of others. So this will be more of a provoking discussion talk than a this is what you should do talk. So yeah, there will be links at the end. And I like that picture. It reflects me quite well, so I included it. So some principles you can use for literally any Python project that you work with. So the next few slides are going to quote very closely from the Hitchhiker's Guide to Python, which has a page on structuring Python projects, which I've borrowed heavily from. So the quote is, dress for the job you want, not the one you have. So this starts from basic things like use version control. Even if you're just writing a one-file script, start a repository for it, because it will probably grow. It always does. You start, I'll just write this in 5 minutes, throw it away, and then move on. And then a year later, you're using it still, and it's 10 files or it's 100 files, and you've got no idea what's going on with it. So use version control to make your life easier. Use tests. Maybe not for a one-file, one-function script, but as soon as you have more than one function, start writing tests. I do not want to press B. Have good documentation. It's, as always, it's a case of do as I say, not as I do. But at least have a README. So you use version control, store on a version control repository like GitLab or GitHub or somewhere where you can see it when you're not on your computer, and where in principle other people can see it if it's not something you need to keep private. And then, yeah, have at least a README so that when you come back to the project in 6 months, you know how it works. Also, then that could extend to using things like ArgParse, where you can make your program self-documenting. Rather than manually passing arguments, use ArgParse, specify a little help text on each argument, and then the --h will give you the help. It will give you the help message. It will tell you how to use your program, which is nice. This is more at the moment. This is just small Python. This is any Python program rather than structure. Use good structure is the next step. And what is good structure? Hopefully, the remainder of the talk will start to head in the direction of knowing what that is. The point is, imposing structure on a large mess is hard. So if you let your program grow to 100 .py files, all in one folder, and all importing each other, then it's difficult to impose structure on it. If you have a neat structured project going in, then by the time you get to 100 files, then hopefully it will still be structured. So, more principles. So, keep the root clean. This is one of the first big chunky pieces of advice from the Hitchhiker's Guide. So, you can have a README, because that's what GitHub or GitLab will display when you go to your project page. You have a license file. There can be files in that name, like maybe a contributing file as well, that kind of thing. The ones you always have in all caps for some reason. Then you have your requirements.txt or your pip file, something to specify what Python packages you need to install into your environment to be able to run this program. Then a tests directory. If you only have 1 or 2 tests, then it can be a tests.py instead. So one thing in the root for tests. Then some documentation. Assuming that you've written some documentation, then it goes in the documentation folder. Then you have a directory with your project name in it. Some people will create a bin directory or a source directory, and that's not so useful because you've got to guess what naming convention this particular project is using. Whereas if it's the name of the project, then it should be pretty obvious it should be in there. You could also have a make file if you want to use make. Obviously you don't have to use make, but it is convenient sometimes in Python. Say if your test suite is slightly tricky to get running, you can use a make file to make that, or if you need to generate a whole bunch of resource files from some packed resources, you can make file to generate those for you. If you're using Django, then you put your manage.py in the root of the repository. The Hitchhiker's Guide goes out of its way to point out that by default, if you just tell Django to start up a new project, it will create a folder and then put a second folder inside that, and manage.py will be buried. So there's a flag you could pass to the generate folder command that will tell it to put it in the current folder, or you can just move it out by yourself. There you'll have various dot files. You'll have things to hook into continuous integration. You'll have .get-ignore file. You'll have all of your little bits of tooling that are generally hidden that exist in your repository. And the reason you keep the root clean, apart from because it's a nice structure, is also because when someone lands on your repository page on GitHub, GitHub at the top of the page shows them a pile of code. And they've got to scroll down to get to your nice documentation, your README file. So if you keep your root nice and clean, they don't have to scroll as far to get to your README. Hopefully the README will partially be on the page as the page loads. So next principle, things to avoid. Avoid circular dependencies. If you have circular dependencies, your code doesn't run. So in some cases, if 2 files do need to refer to each other, then you can structure your program so that you only import within a particular function. So then at least the project will run because it will be able to import one from the other. But you want to avoid that as much as you can because it's a mess. You want to have a nice clean dependency graph if you can, so that you know that there's some hierarchy of what builds on what. Also, things to avoid hidden coupling. So this is where I've got 2 functions. I think the Hitchhiker's Guide called them table and clank or something, or table and share or whatever. And say you change one thing in table, and then suddenly the entire of chair breaks because everything inside chair makes a whole bunch of assumptions about the exact way that table is functioning. So that's a hidden coupling. You want to try and keep things to using defined interfaces and boundaries, and then so that they don't care about what's happening internally to each function. Similarly, try and avoid using global state and context. So in compiled languages, this is the same as having a bunch of global variables flying around. Python takes it a step further. You try and be as context-free as you can, so then as many functions as possible are pure functions. So they take in some state as arguments, they pass out some state as return values, and they don't modify their environment. If you're using things like PyPy that do optimization, then it makes life easier for them. It also makes it a lot easier to visualize what's going on with your program. You know, you're explicitly telling yourself and anyone else who reads your code what variables you're going to modify at any point. An example of something that doesn't do this is matplotlib, the pyplot interface to matplotlib. This is entirely stateful. It has hidden variables everywhere, and you're just calling imperative functions that have no arguments at all, and it's modifying everything. So that's why, in general, people recommend you use the object-oriented interface to matplotlib if you're taking it seriously, because when you build larger programs out of it, it's a lot easier to manage. Spaghetti code. I think we all know what spaghetti code is. How many of you have heard of ravioli code? How many of you don't know what ravioli is?
I'm not 100% sure.
I'm not sure what spaghetti code is.
So spaghetti code is where you have very, very long functions. So you fail to separate your concerns, and so you end up with lots and lots of loops, really, really deep nested loops, and really, really long functions, where in fact it's doing a lot of different things that could be separated out into different functions. And so then it gets very difficult to manage because you've got to keep track of a whole lot of state in your head when you're reading the function. Ravioli code is the opposite, is where you separate things out nicely into tiny, tiny little classes, and you have hundreds and hundreds of little classes, all of which are completely independent of each other. And then there's no interconnecting structure to them. So the example that Hitchhikers gives is, say you don't know whether you're supposed to use chair or stool or new chair or chair 2.0 or whatever. But that's ravioli code. You've got too many classes. You don't know how to use your program. So some more generic considerations. Object orientation considered harmful. I just realised Jonas isn't in the room. Jonas requested this talk. He's not in the room.
Yeah.
He's away for Easter. But I guess he might start an argument about this. But Python is an object-oriented language in the sense that it has everything is an object. Functions are first-class objects, but it doesn't make you program in an object-oriented style in the way a language like Java does. So you can write code with a very small number of classes and having a lot more procedural things, or functional things if you like to program that way, and that can make your program easier to manage. You can also separate concerns with decorators. How many people have used decorators in the room?
What is a decorator?
What is a decorator? It's a function that modifies a function. So it's you have a function that takes a function, does something to it, and returns the modified function. And you can apply it to a function by putting an @ sign and then the name of the decorator above a function declaration. And this is useful for things. The ones that always are used as examples are things like where you want a function result to be cached. If you're writing a web app, you want to cache the result, you stick @cached above the function, and it automatically inserts some tooling that caches the result.
I've seen that.
Yeah, it's useful because it's safe having a load of boilerplate at the top of each function, or having a function called to something at the top of each function. Again, I have never written a decorator, so this is a case of this is something I'm going to try and do more if I can see cases where it's useful is web decorators.
So is it the same as implementing something in Java?
I have never written a line of Java, so I can't answer. Has anyone written Python Java and can answer that?
No. Decorators are basically, yeah. We'll have a good point, a bit of depth maybe afterwards. But basically, you just you have a function that behaves in a certain way, and then you have another function that you pass that function into, and it returns a modified function essentially that behaves in a slightly different way. Maybe you've wrapped it and done something to the function, and then you use that to replace the original function.
Yeah, okay, I can't think of...
I don't think there is an equivalent in Java, as far as I can think off the top of my head.
Are functions first-class objects in Java? Do you need functions to be first-class objects to be able
I'm not
to?
aware of them being first-class objects.
Yeah.
I think that they're not.
What is a first class object? Exactly. I mean,
It means you can pass around a function like any other object.
Functions can live in variables.
Yeah. Okay. So it's okay.
Yeah, you don't need to make pointers to them or anything. You can treat them exactly like you treat a list.
Yeah. Okay.
So next was use context managers when you have something that needs both setup and teardown, because otherwise you will always forget to do teardown, and you will end up with memory leaks and just there are things hanging around where they shouldn't be. Where context managers make that nice for you. Again, I have never written my own context manager, but I do always use with when I'm opening files. So that's the case you're most likely to encounter context manager is a file object. You open a file, and rather than having a closed file later on, you say with open as file object. Also, avoid reusing names for different types. So if A is a string on line 1, it shouldn't also be an integer on line 5, because it will make your code far harder to understand. So next, modules and packages. So it's quite hard to talk about structuring Python projects without talking about modules and packages. So the really quick way of saying this is modules are .py files. In general, you want your modules to always be usable as modules. So you know that .py files are also Python programs, you could call them scripts, but you want to be able to import their functions into other modules, and so you use this construct if _main equals main, then that will only run if it's called as a script. If it's imported somewhere else, it won't. And if you look at examples of code online, you'll see that all the time. And until you get used to using it, you wonder why they've been inserting this boilerplate everywhere, and then you start doing it yourself. It's like, why would you not do that? And packages are just folders that have a dunder init.py in it. Yes. So normally this dunder init is empty, because if you have a long tree of packages that contain packages that contain packages, if you import a package at the lowest level, it has to pass and run every single init file in the tree that goes down to that. And you don't want that overhead every time you call one of your third or fourth level packages. So you keep the init file as empty as you can. It just lets Python know this is a package. And because of this, your directory structure is your API. So it's not like a language like C++ where you define your API in a bunch of header files, and then that could just be a flat folder of files. Your directory structure has a one-to-one map, or maybe 1 to 1.01. I think there are things you can do that will modify that, but in general, your directory structure maps very closely to your API. And you can kind of view this, I think, like how whitespace is syntax in Python. It enforces you to use good whitespace because the whitespace is the syntax. In the same way, it enforces you to have some kind of directory structure because the directory structure is your API. So if you want an API that has structure, you have to structure your folders. So next, things about how you can manage your dependency graphs. So I like to call this the Amazon principle. So for those of you who don't know this story, Jeff Bezos, the CEO, I think he is, of Amazon, enforces this philosophy that each business unit in Amazon has to treat every other business unit as a customer. And they have to sell their services to the other business units. And so Amazon's hosting entity that hosts Amazon.com and Amazon.co.uk, JP, all the others, obviously Amazon is a heavily trafficked site, so they had to be a very powerful hosting entity, and they sold their services to the rest of Amazon. And then at some point it was like, we have very good value for money on our hosting, maybe we should offer it to the rest of the world. And so AWS was born and has become a huge business for Amazon. So in the same way, you should make each package so that it can be consumed from outside, and each package that you want to use, you should consume via its public interface. So if there's something you want to do with another package in your project that it doesn't currently support, you shouldn't then hook into that package's internals and then pull out bits of internal state. You should make it so that that can be done via a public interface, so then when you want to do it again from another piece of code, it's easy. The other thing is divide and conquer. So divide your big, huge project into small packages that do something and do it well. So, for example, you don't have a single carpentry workshop app. You have a module that does, say, planing really well. You have a module that does carving the ends of bits of wood really well, that kind of thing. And then you could have some kind of thing that makes tables and pulls in from those modules, pulls in from those packages rather. And similarly, then you have this hierarchy of packages. So you have some packages that consume and some packages that are consumed, and obviously packages that are designed to be consumed shouldn't have very many dependencies because you want them to be relatively light. So for instance, in matplotlib, you have matplotlib.colors, which just contains things to do with colors and doesn't depend on anything else. And then that's used by matplotlib.lines and a bunch of other classes and packages within matplotlib. And then lines is used by axes to generate plots. So things are used by other things and shouldn't need to go swim back up the other way. There should be a nice flow. Also, fully qualified imports. So to use it when you use the public interface of the packages in your repository, in your program, avoid using relative imports. So in Python, you can import from the current folder, or from the parent folder, or from the parent's folder if you want to, using dots. That's not generally a good idea. So you want to try and use the public interface where you can to enforce this Amazon principle. Of course, qualified imports will only work if the package is installed, unless your Python path is set up appropriately. So we have to adjust the search path to account for this when we're testing on something that hasn't yet been installed. But yeah, the Python path is something that you end up butting up against if you don't learn about it. And I have not learned about it to the point where I'd want to include a slide on it, but I know it's something that in the next few hours of Python programming, it's probably going to be something that I'm going to learn, because everyone always ends up saying, when you talk about Python packaging, especially when you're talking about using modules effectively, then it's always, oh, you need to know exactly how your search path works here. So learn about Python search paths. Maybe at some point there can be a talk about Python search paths. It will last about a minute.
Mm-hmm.
So I asked my Twitter timeline, what are some good examples of huge Python projects that are well structured that I can work for? And Frank James replied to me saying OpenStack. And it was the only reply I got, so we're going to look at OpenStack. So OpenStack Nova is the main component of OpenStack. I know almost nothing about OpenStack, so I just went for their most recently updated and biggest repository, and that was called Nova. And this is a really, really simplified dependency graph for OpenStack Nova. If you think it's complicated, you should see the non-simplified version, which I don't have up on the slides because it is basically grey because there's too many lines.
So in which way simplified?
In which way is it simplified? So it only looks at things that exist in the top level of the application. So the main packages and then any .py files that sit loose at the root level. Not the root of the repository, but one level down in the Nova folder.
So it's essentially your first level dependency.
Yeah.
It's pretty much a complete graph, isn't it?
What doesn't show up well on this projector is the arrowheads, so showing the directionality of the dependencies. So you can just about see that there's a thick blob at the end of the line and then no blob at that end of the line kind of thing. So there to there, there to there. I haven't found a good graphing app that will display this in a way that makes it clear that it is relatively hierarchical and there are no circular dependencies. I drew a simpler graph and it was able to do that, but as soon as it got something as complicated, it failed horribly. So the other large Python project I'm aware of is Django, whose graph looks like that, which is slightly simpler.
Again, simplified.
But yeah, this is simplified in exactly the same way. The only other thing I've done, I think I've done it in both cases, so there are modules that hold configuration options that literally everything the application refers to, and I've removed that. And also internationalization, every file in the application refers to the internationalization module, and I've removed that. But apart from that, everything's there. And so here you can see there are some circular dependencies. You can see, like here, you've got a thick double-ended arrow there. Those. And then also this one, that one, that pair as well, that pair as well. So yeah, Django is a lot messier in terms of its dependency management. It has a lot of circles, and you can quantify that. So Nova has very few backwards imports, and so very few effectively circular imports. Not quite circular because that would make the app not work. Specifically, if you go and look for instances where the import statement is indented, so you grep for the import keyword, you grep for Nova, and then you grep for a space at the start of the line, you get 32 out of 7,000 import lines are indented, which means that they are occurring inside a function, so they're being done so that you don't create a circular dependency. On the other hand, it does have a lot of .py files at its top level, and I'll bring the repository up in a second to look at. And it's kind of wide and shallow, and I'll explain what that means. Django, on the other hand, has many backwards imports. Django has, that's a typo, I think that should be 3,053. So about 10% of its imports are indented, which isn't great. It makes it a lot harder to see what's going on. You've not got this waterfall-like structure of dependencies. There are approximately no top-level .py files, which is nice. And in general, it's narrower and deeper. If I just open, that is actually the wrong Safari window. So I want that one. And I want it to be on this screen. So this is OpenStack Nova. So I'll start from the top level of the repository. So you can see at the top level of the repository, we have Nova, we have doc, we have a few other things. We have some tools, we have some release notes, we have this gate thing, which I tried to work out what it is. I'm not at all sure. It's a piece of internal tooling for when OpenStack deploy, I think. And because their entire repository is public, they can't hide it, so it has to be there. Now we've got our dot files for tooling, we've got our all caps files for users, then some configurations for testing, and requirements.txt. So all the things that we said should be there are there, and not much more. A little bit more in the way of folders. So we go into Nova. Oops, so you can see there's quite a lot of folders here, so there's quite a lot of packages in this package. And then there's also quite a lot of bare.py files in the root of the package. And I did for an hour this morning try and manually draw the dependency graph on a package basis of this, and eventually gave up because there's so much stuff that depends on these root files. It's not very pleasant. Which is part of the reason it ends up getting so complicated on that dependency graph compared to the Django one, for instance. Obviously, the Django one's also half the number of files, and so when you start drilling down into folders here, you can see there aren't very many subfolders per folder. So you get folders with loads and loads of .py files and no subfolders. So that's what I mean by wide and shallow. You don't get many layers of subdirectory. You do get lots and lots of .py files. Whereas if we look at Django, we go to the recent Django. Similarly, we have a smaller number of directories here. We have some tests, we have Django, we have some tooling, we have some all caps files, and we have a setup.py. And then we go into Django, and you can see there's init.py, which we have to have, there's main.py, which does setup, and there is this one shortcuts.py. Apart from that, there's no .py files in the package root. And then as we drill down into core, there's a few .py files and then a bunch of folders, and we go down a little level. And in some cases, you start going down, and core is not the best place to look at that, but I think random folders earlier would work really well. I think random folders, and I'm seeing more shallow bits. But you can see each folder is smaller, and then you go down. And depending where you look in the repository, there's a bit more depth. You get more layers. I did not want to open that. Okay, but yeah, so there are some trade-offs with that. I'm not sure whether wide and shallow is better, whether narrow and deep is better. Obviously, wide and shallow means that when you're reading documentation, then each module has a really, really long documentation list because it's got so many functions at each level. Whereas narrow and deep means you have to have lots of dots in your imports. You have from Django dot whatever dot whatever dot whatever dot whatever import. Whereas you don't get that very long import line when you're using Nova, I guess. Obviously, I haven't programmed against Nova, so I can't talk much about what the experience of that is. So, yeah, that was kind of all I had to say. I've kind of run out of steam now, and at that point, I think it's good to chat about what everyone else thinks about the structure of large projects, because, like I said, as I confessed at the start, I haven't made large projects, so I'm going on what I've read, and obviously, if anyone else has stuff to share, that's great. So references, I use the Hitchhiker's Guide heavily. The two repositories I've just shown you are there. And the dependency graphs I generated with a tool called Snakefood. Incidentally, the Django one, it was an old version of Django I had to use because the version of Snakefood I was using didn't work with Django, the latest version of Django, because I think it didn't like Python 3 syntax. But yeah, it's kind of nice. It can generate these dot files that will then render to PDF or SVG or whatever you want. And for small repositories, I think it's more useful because then you can actually get a better handle on what's going on with your dependencies, and you'll also know all of the words in the graph, so it'll make more sense to you. But yeah, at that point, it'd be good to chat about dependencies and packages in Python.
Thank you, Ed. So